Hi, my name is Megan Daw. I supported much of the work for Palo Alto's REACH Code Cost Effectiveness Study. Today I'll be going over the non-residential measures we looked at in the study. I'll give a brief overview of each measure and how they can be modeled in California's compliance software. Hopefully you can use some of these measures in your projects to comply with Palo Alto's ordinance. So now we'll get into the non-residential measures we looked at for the REACH Code Cost Effectiveness Study. I'll give a brief overview and how to model each. For Palo Alto's REACH Code, there are two pathways for non-residential new construction. The first is to show a 10% compliance margin with Title 24 without installing PV. The second pathway is to install a minimum 5 kilowatt PV system. I'll be focusing more today on how to achieve the 10% compliance margin. I'll go over the simulation software we used and the sources of each measure that I will show today. For each measure, I'll give a brief description, demonstration of how to model this in the California compliance software, and we'll track the impacts of each measure as we apply them to our building. Lastly, there will be some conclusions and additional resources for each of the items I spoke about today. Today, the software I'm using is CBEC-COM. This stands for California Building Energy Code Compliance, and the COM represents commercial buildings. The version we're using is 2016 1.0. This software is used to model many types of commercial buildings, such as office, retail, high-rise multifamily, and additional. We'll be looking at office buildings today. Currently, other approved software for the commercial projects is Energy Pro. The prototype I'm using today is a medium office. It's a 3-story, 53,600 square foot prototype with 3 packaged VAV systems, 1 for each floor, and 2 boilers. It's in California Climate Zone 4, which is where Palo Alto is located, and it is exactly compliant with Title 24 prescriptive requirements. I will not be going into how you produce this particular prototype. If you want more details, you can look at the Non-Residential Alternative Calculation Method reference manual, where there are many details on how the CEC has come up with this particular standard design. For one of the measures, the economizer measure, I'll also be looking at a smaller office prototype. This is about 5,500 square feet, 1-story system with 5 packaged single-zone air conditioning systems and a furnace. It's also located in Climate Zone 4 and exactly compliant with Title 24. Again, you can refer to the Non-Residential ACM reference manual for more details. A brief overview of how the compliance software is set up. You'll have your envelope tab, which is where you can build the geometry of your building and insert items such as total square footage, the number of floors, and then features for each floor. So here we have a bottom floor, a mid floor, and a top floor. Within each of these, you then develop your areas and each of the exterior wall and interior wall assemblies, as well as your windows, your floors, and your roofs. Next, we have the mechanical tab, where you can build your mechanical systems, such as your heating and cooling systems, your service hot water, and your domestic hot water. For this particular building, we have packaged VAV systems, and all of the details can be found here. After implementing energy efficiency measures, you can run the simulation software, and this is the output you will get. On the left-hand side, we'll see the standard design energy use for your building if it were perfectly compliant with Title 24. That is then compared to your proposed design that incorporates all of the energy efficiency measures you have implemented in the project. And our compliance margin shows us how we are performing versus a standard building. In this simulation software, this compliance margin is just the difference between your proposed design and the standard design. To actually see what % compliance we are above Title 24, you can either do the calculation, or if you print out the PDF of your simulation results, You'll see here our compliance total for this project was 11%. And do note that for the commercial building software, indoor lighting is included in this compliance total. Today I'll be going over the non-residential measures that we looked at in the REACH Code cost effectiveness study. We used these measures after looking at various measures and determined that these were both technically feasible and cost effective. The non-residential measures we're looking at are economizers for the small office building, cool roofs, and various indoor lighting measures. I'll go into a brief explanation for each and show you how to model those in the compliance software. The simulation results you're going to see today may be slightly different than those that are in the REACH Code cost effectiveness study. That is because the REACH Code cost effectiveness study blended the results from both the medium office and the small office, as this is more representative of the construction in Palo Alto. The results might also be slightly different than those you would receive in the future modeling. That is because if you're using a future or later version of the simulation software, there are slight updates made and the results may be slightly different. One of the indoor lighting measures we're going to look at today is not actually available currently in the CBEC model, the CBEC COM software. We'll go into some brief overview of how we approached the energy savings and what you need to do to show compliance with this measure for Palo Alto. For the small office, we implemented an economizer. The economizer is prescriptively required for systems that are greater than 54,000 BTU per hour. The Title 24 requires an integrated economizer for these systems. The measure we looked at is for a smaller office with a smaller system size, and we also implemented an integrated economizer. So let's look at the model and see how you would model this. This is our small office prototype. It was perfectly compliant with Title 24, showing a 0% compliance margin. On the mechanical tab, for each of the packaged single zone systems, we'll go to the outside air control, and we will select the fixed dry bulb economizer. It will be an integrated economizer. And for our purposes, we set the parameter at 72 degrees for the high dry bulb temp lockout. These parameters can be set specifically for your project, and they may be different for each project. For the purposes of this, I've already gone through and changed the rest of the systems, but you can always double check by pulling this drop-up menu and making sure that each of your zones has installed the economizer. We'll save and run the simulation. So you can see with the economizer measure for the small office, we received an 8.7 compliance margin. You'd have to do a little bit of calculation to see what our percent compliance above Title 24 is, and I have already done that. So that measure alone, in the small office, we received 5.2% compliance margin. So we're a little bit more than halfway there to reach the 10% compliance margin required by the ordinance. Next, we looked at implementing cool roofs on commercial projects. Title 24 currently splits cool roof requirements by the slope of your roof. Typically, for non-residential and office building projects, there is a low-sloped roof. However, the small office actually has a steep slope roof. The current Title 24 requirements is an age solar reflectance of 0.2 for the steep sloped roof, and those are more typical of using either concrete tile or asphalt shingles, as shown on the left-hand side here. For low-slope roofs, or sometimes commonly referred to as flat roofs, the age solar reflectance requirement in Title 24 for Climate Zone 4 is currently 0.63. We are increasing both of those steep slope and low sloped cool roof requirements to an age solar reflectance value of 0.28 for steep sloped and 0.7 for low sloped. I've jumped here to our medium office building, which is the 3-story building. To implement the cool roof, we first look at our top floor where the roof assembly is. Right now we can see it's using a roof that has solar reflectance of the prescriptive values, 0.63. So in order to update this, you can either change this directly, or I always like to save a new construction assembly so I don't get confused. So here I developed a cool roof for climate zone 4. It has the values of 0.70 for the age solar reflectance. We then apply that construction assembly to our building. You can now see how it's changed the age solar reflectance to match our design requirements. We save and we run. All right, so our simulation finished, and for just installing cool roofs on our medium office, we only received a 0.2 compliance margin. So let's see what that looks like as a percentage. So our 0.2 compliance margin actually equated to a 0.2% compliance margin. So to reach 10%, we're going to need to install a few more measures. The next set of measures we looked at are to improve indoor lighting. The first is to reduce the lighting power density in this space, the LPD, and there are actually a couple measures that go into this. The first is to reduce the watts per square foot by installing higher efficacy lighting. We averaged the spaces and the percent of reduction that we could get, and that averaged to about 0.05 watts per square foot. The next measure would be to implement institutional tuning. This is a practice where at commissioning, lighting would actually be adjusted down or tuned down to an appropriate level. This reduces the lighting to the space and reduces the watts per square foot. Now these two measures aren't additive, they're overlapping in savings. So when we calculated the overlap, the equivalent LPD of the space will be at 0.63 watts per square foot, which is a significant reduction from the Title 24 prescriptive baseline of 0.75 watts per square foot. The second lighting measure we looked at is to implement daylight dimming plus off. Under Title 24, spaces that have adequate daylighting reduce their lighting power down to 20% of the fully installed power when that daylight is available. Under this measure, that lighting would be reduced down to 0. So essentially lights could be turned fully off when there's adequate daylighting. So let's see how that looks in the model. For daylighting, each of the spaces has their own LPD for that particular space. So we can see in this space the 0.75 watts per square foot, which is the prescriptive value. So we're going to reduce that down to 0.63, which is the calculated LPD we got from our measures. An easy way, instead of going back out to the model and finding each of your spaces and potentially missing some, is using this drop down and changing the spaces here. As you can see, I've already gone through and changed all of the LPDs for all of our spaces. The next measure is daylighting, the daylighting control. Again, we go over to the daylighting tab, and this measure is really only going to apply to our perimeter zones where daylight is accessible. So we changed the control type from just continuous, which has the maximum, we changed this control type from continuous, which has the minimum dimming power fraction of 0.2, to continuous plus off. And that will essentially tell the model that your lighting can be reduced down to 0. Again, we'll go through all of the perimeter zones and make sure that continuous plus off is selected. Once you've done that, you can select OK. You would save the model and run it. Our analysis results, and this includes both the cool roof and the LPD reductions and the daylight dimming plus off, gets us an 8.1 compliance margin. So let's see what that where that gets us in our percent improvement. So with those two measures, we are now at 7.9%, so well on our way to the 10% requirement, but we'll need one more measure. The last measure is also a lighting measure. This one is open office occupancy sensors and cannot actually be currently modeled in the compliance software. So in order to show compliance with this, if you choose to use this measure, open office occupancy sensors is a power adjustment factor available under Title 24. So how you would show this is filling out the associated compliance form noted here and submitting that with your energy model. The one note that should be made is the nature of power adjustment factors is that by saving and implementing a lighting reduction measure somewhere, you are then allowed to install higher LPDs elsewhere. That should not happen if you are taking this as a compliance measure. You would fill out the form and then not increase installed wattage elsewhere. We calculated these savings separately, and this will have to be done on a project-by-project basis. And I will note in our analysis, we accounted for overlap in savings from the other lighting measures I just described. So we took sort of overlap of the lighting measures we already had, saw the lighting energy use in our proposed building, and calculated that installing occupant sensors would reduce our energy use by 2.9 kBTU per square foot. So that's subtracted from the previous value we had from all three of our measures to arrive at 91.3 kBTU per square foot and our 10.7% total compliance margin. So we've met our goals with a few measures here. In conclusion, again, these are some packages of measures that we used during the REACH code cost effectiveness analysis. They're not the only measures you can use to comply with the REACH code. If you're looking to install other types of measures, you're encouraged to focus on some of the largest compliance loads. For the office, it's likely your cooling and lighting loads. You can also consider envelope measures, such as improving windows, installing skylights, or improving the thermal envelope, such as your wall assemblies, HVAC fan efficiencies and system efficiencies, and also looking at some of your domestic hot water loads and how those could be improved. We don't suggest that you look at PV panels. Under Title 24, you cannot claim any compliance credit for those in the non-residential software. However, for Palo Alto's REACH code, you can install a 5 kilowatt PV system or larger and comply with this code. You cannot do it in the software. We also don't suggest you look at receptacle loads or process loads, as those are set and are not adjusted in the compliance software. Your proposed building will always be equal to the standard design. You can't claim any credit there. Lastly, here are the resources I discussed today. The CBET-COM modeling software is free for download and is provided by the California Energy Commission. The REACH Code Cost Effectiveness Study, which has further details about all the measures I described today and additional information on the costs and energy savings. The non-residential ACM reference manual provides instructions on how to model additional energy features and how to produce your prototype buildings. And the indoor lighting case report, which describes how we use some of the estimates and assumptions to calculate the occupancy sensor savings. So with that, I wish you good luck on all of your future projects and hope this was helpful for you today.